Okay, so today we are going to start chapter 3. See, in chapter 3, we are going to talk about exponential and logarithmic functions. I hope you all may have done these in school. So what do you mean by an exponential function? So an exponential function is defined by fx equals bx, right? So that's an exponential function. Right? So an exponential function. So here over here we say it has base b and exponent x. So if the base b is positive, we draw this. If b is greater than 1, this is the shape of the curve. And if b is between 0 and 1, that is something like 1/2 to the power x. So this is the shape. So it's like y equals 1/2 to the power x, where b lies between 0 and 1. And this red curve is for all the values b greater than 1. This is like 2 to the power x, 3 to the power x, right? So these curves will have this shape. Whereas if b is between 0 and 1, it will have this green color curve shape. Now let's look at the properties, okay? The properties. So what are the properties of exponential functions? So the domain is from minus infinity to infinity. You can see that. Now x, that is the values of x, lies between. So if you take this graph, just one graph, it goes from minus infinity to positive infinity. The range is always positive. Look here. It is not defined for negative values of y. The graph does not go across the x-axis. It does not go below the x-axis, which means the range is always positive ones. So the range is from 0 to infinity, right? Whatever it is. It does not go below x-axis. So range is positive ones. And graph always passes through the point 0 and 1. So what does it say? When x is 0. Now for example, I wrote y equals 2 to the power x. Right? 2 to the power x. So when x is 0, what is 2 to the power 0 equals to? 2 to the power 0 is 1. So any number to the power 0 is 1. So always this passes through the point 0, 1. It always passes through the point 0, 1. So even if you take 1/2 to the power x, when x is 0, this will be half to the power 0. Half to the power 0 is 1. So always it passes through the point 0, 1. These are the properties. So again, x ranges from minus infinity to infinity, that is the domain. Y is from 0 to positive infinity. It does not cross the x-axis, go below the x-axis. And this graph always passes through the point 0, 1 because this is an exponential function. So if you plug in x equals 0, you get y equals 1. Now let's look at the base. So as n gets larger and larger, the value of the expression approaches the, so here this is something, a rule. 1 plus 1 over m to the power m approaches the number 2, 0.71828, which is denoted by e. Right? E is the exponential function. So it also has the same shape. So if you have y equals ex, this is the shape. And if you have y to the power minus ex, that is like this. Y equals 1 over ex. Remember we wrote 1/2 like that. So 1 over ex is same as y equals e to the power minus ex. So it has this shape. This is y equals minus ex. And if it is positive, it's the other way around. So again, the domain is from minus infinity to infinity. Range is from 0 to infinity, and always it passes through the point 0, 1. That is when x is 0, y is 1. If you plug in x equals 0, y equals 1. So those are the three properties. Domain minus infinity to infinity, range 0 to plus infinity. And it passes through the point 0 and 1. X is 0, y is 1. So here I have plotted the graphs using the values. If you plug in x equals minus 3, minus 2, minus 1, you get this and you can plot it. Same here. Okay, now here I have given you two questions asking you all to solve for x. You all know this. This is from school only. Right? Grade 7, 8, they do these type of questions. Can you all please try these two out and give me the answers? I will, ask you all. Right? Pick one of you and ask you for the answer. So because of that, all of you, please solve these two.
Recording stopped. Recording in progress.
So how do we solve this? You have to bring both sides to one base. So 2. So 8 is 2 times 2 is 4, 2 to the power 3. And then next I write it outside. Equals 32 can be written as 2 to the power 5. 2 to the power 2, 4, 8, 16, 32. 2 to the power 5. X minus 2. Right? Now the basis has to be the same if in order to equate the indices, right? The exponents, if you want to equate the exponents, the bases should be the same. So what do I do? So here I have 2 to the power 3x. And here I bring 2 to the numerator and make it minus 5. And then into x minus 2. Now I can equate the exponents. So here we have 3x minus 5x plus 10. Right? So 8x equals 10. X equals 5 over 4. Is this okay? Did all of you get this? Did you all solve it? Did you all get the answer? Yes or no? Okay, great. Now let's see this one. So can you see now here we have 3 to the 2x. Here we have 3 to the x. So what does it look like? Can I do this? Let 3 to the x equals y. Then here it will be 1. 3 to the x is y. So this is like y square. Right? 3 to the 2x. So 3 to the x is y. So y square minus 3 to the x is y. 12y plus 27 equals 0. Right? So do you all understand? Here it's 3 to the x. So it's like this. 3 to the x into 3 to the x. So 3 to the x is y. And this 3 to the x is also y. So it's y square. Now we can factor this. Multiplies to give 27, adds up to give minus 12. What is it? What is it? Y minus 9, y minus 3 equals 0. Y equals 9, y equals 3. Y is 3x. 3 to the x equals 9. Here 3 to the x equals 3. And here, so x equals 2. Right? 3 to the x is 9. 9 can be written as 3 to the 2. So x equals 2. Here what is x? X equals 1. Okay. So that's how you solve it. You can write it down. And if you have any questions, please ask. It's 9. 9 is 3 square. Here 3 to the x is 3. X equals 1. Any questions? Is it okay? Do you all have any questions to ask? Okay, then the next topic. Logarithmic function. So what are log functions? So if you have log y log b to the x, this can be written as x equals b to the y. Example, log base 10, right? 100 equals 2, right? So this is the simplest logarithm that you all have learned. So this is same as writing what? Base 10 to the power 2 is equal to 100. Right? Here you take this base 10 to the power 2 equals 100. So now see this one. Log base 3, 1 over 27. So we know 1 over 27 is 1 over 3 to the power 3. Right? So this can be written as let me erase this whole thing. 1 over 27 equals 1 over 3 to the power 3. Okay? So log base 3, 1 over 27 can be written as log base 3, 1 over 3 to the 3. So this can be written as log base 3, 3 to the minus 3. And remember, using log properties, you can bring this minus 3 to the front. Minus 3 log base 3, 3. So you all know this is equal to 1. 1 times minus 3 is minus 3. You may copy it down. Okay, you can copy it down. Is it okay? Did you all do it? Are you all done? Okay, let's see the next problem. Number 3, solve log this one. So remember the rule that I said log 10, 100 is 2 now. We have 10 to the 2 is 100, right? So you can apply the same rule over here. That is, you can take x to the power 3 equals 8. So 8 is 2 to the power 3, which means x is 2. Here, log 3 to the power x is 4. So how can you do this? You can apply that same rule. P to the power 4 equals x. 81. Okay? Is this okay? Any questions? Then we have the laws of logarithms, right? We all have done all this thing. Until page 5 you have learned in school. So we have the properties of log. You all know if we have log m to n is log b m plus n. Division, log division is log subtraction. If you have m to the n log m. And any log base 10 to the power 1. Any base to the log 1 is 0, right? And log, if you have log base 10, 10. This is equal to 1. Log base 2, 2. This is also equal to 1. So examples, log base 10, 6. So this can be written as, right? So if you have log base 10, 6, this can be written as log base 10, 2 times 3, which is equal to log base 10, 2 plus log base 10, 3. Log base 10, 3. Right? So 2 times 3 is this. What about this? Here we have log base e. Okay, so something new. Log base e is same as ln, natural log. Ln means natural log, right? Earlier I told you all natural log means 1 plus 1 over m to the power n. E, the value of e 2.7 point something. So log e is natural log. So here we have log base e 5 over 3. So how do we write this? Log or ln natural log 5 over 3. So ln 5 minus ln 3. If it is division, it's subtraction. If it is multiplication, it's addition. Okay, then we have log base, log, if they have a not, I mean, here I haven't written the base, so which means 10, okay? If the base is not written, it is assumed to be 10. So log base 10 root 5 is 5 to the power 1 half. And remember, I told you all that you can bring this power to the front. So 1 half log 5. And any base to 1 is 0. Because 2 to the power 0 is 1. And here log base 5 to the 5 is 1. Okay. So now solve these problems using the properties of log. Please, all of you solve it. I will ask you one. Okay, I will ask out questions. So make sure that all of you solve. There are 2 questions, so make sure that you all solve them. So did you all solve? How can we solve the first one? So the bases are same and we can just simply divide. Log base 2 x divided by x minus 2 equals 3. Right? And how do I get rid of this log base 2? Remember log base 10 100 equals 2. And if I take it 10 square equals, so 100. So here also I can do the same. X divided by x minus 2 equals 2 to the power 3. X over x minus 2 equals 8. Now you can solve this. X equals 8x minus 16. 16 equals 7x. X equals 16 over 7. Then the next one. Since it's adding, it's multiplication, right? X into 2x minus 1 equals, so here the base is not written, so it's assume log base 10, log 6. So in both sides you have log, you can take 10 to the power on both sides and remove the log. So you have x 2x minus 1 equals 6. Please solve it. So what did I do here? Log base x into 2x minus 1 equals log base 6. Right? So if I take 10 to the power, I can remove the log. Here also remove the log. So we have x into 2x minus 1 equals 6. 2x squared minus x equals 6. Now factorize it. Minus 6 equals 0. Now please factorize it. So can we factorize this? Multiplies to give minus 12 adds up to give minus 1. So minus 4x plus 3x. 2x, x minus 2, x minus 2. So we have x minus 2 into 2x plus 3 equals 0. So one answer is x equals 2. The other answer is 2x plus 3 equals 0. X equals minus 3 over 2. Now when you have a negative answer, you have to be careful. If I plug in minus 3 over 2 over here, 2 times minus 3 over 2 minus 1. So I get log minus 4. Is log minus 4 defined? Is it defined? No. Log is not defined for negative values. So this can't be an answer. Right? X equals minus 3 over 2 can't be an answer because log is not defined for negative values. So the only answer is x equals 2. Did you all understand? So if you get a negative answer, you have to check whether it satisfies this because log is not defined for negative values. Okay? So, see, log is not defined for negative value. So, the only answer is x equals 2. Now, do you all have any doubts to ask? Any questions? Okay, if not, the next topic is properties of log. So, just like for exponential functions, there are some properties for log as well. The domain is 0 to infinity. Remember now earlier also I said log is not defined for negative values, right? Log is, so log minus 4 does not exist. So log is not defined for negative values. So the domain is from 0 to infinity. So if we draw the graph of ln x, that is log base e. ln is log base e, right? So the domain is 0 to infinity. X can range from 0 to infinity. It cannot be negative numbers, right? This is does not exist. Minus 4 is not defined. But however, the range, that is the y values, the answers that you get over here, it can be minus. So it ranges from minus infinity to infinity. The domain, that is the x values, can't be minus, can't be negative, right? Can't be negative, and also it can't be 0. Why it can't be 0? Because when x approaches 0, ln 0 approaches minus infinity. See the graph? It goes towards minus infinity. When x approaches 0, ln 0 goes to minus infinity. And when x approaches infinity, ln x, sorry, here it should be ln x. Ln x approaches positive infinity. And it passes through the point 1, 0. That is ln 1 is equal to 0. Log any base to the 1 is 0. That we did it in the properties as well. Right. So you should be familiar with these. When x approaches to 0, it goes to minus infinity. When it goes to positive infinity, it goes to positive infinity, and ln 1 is 0. So the domain, the x values are from 0 to infinity, but here parenthesis not closed because 0 cannot be included. Range can be minus infinity to infinity. Alright, so those are the properties of the log function. And then we have these two properties, e to the ln x is x. So how do we do this? Remember composite functions, we use composite functions. So f of x is e, g of x is ln x. So we have f circle g of x, which means f of g of x. Right? F circle g of x is f of g of x. So instead of g of x, we write ln x. And ln x is f of, instead of x, we have ln x. So e to the ln x. E to the ln x is x. Right. So these two properties you have to remember. E to the ln x is x and ln e to the x is x. So here this is like x ln e, ln base e, e. Right. So ln base e, e is 1. 1 times x is x. ln base e is 1. 1 times x is x. So please remember these two properties. E to the ln x is x. Ln e to the x is also x. Now let's see these problems. First one, 4e x minus 1, 8. So here again, we can cancel these. 2. E to the x minus 1 is 2. Right? Now we have to remove this e. We know ln e to the x is x. So we take ln on both sides, not just on one side, on both sides. So if you take ln on both sides, you have ln e x minus 1 equals ln 2. And from here we get ln e to the x minus 1 is x minus 1. Right? ln e to the x minus 1 is x minus 1 equals ln 2. So x equals ln 2 plus 1. Take this x minus 1 out. So ln e is 1. So ln e x minus 1 is x minus 1 equals ln 2. Remember, if you are taking natural log, you have to take natural log on both sides. Not just on one side, both sides. See, on the left also I have taken ln and here also I have taken. Second problem, how do I solve? So 5 ln x equals minus 3 ln x equals minus 3 over 5. Now I have to remove this ln. So I take e on both sides. E to the ln x is e to the minus 3 over 5. E to the ln x is x equals e. So remember once again the two rules. E to the ln x is x. Ln e to the x is also x. The average lifespan for an American from 1907 through 2007 is given by this equation, where t equals 1 corresponds to the year 1907 and t lies between 1 and 6. And this is measured in 20 years, every 20 years. So 1907 is 1, then 1927 is 2, 1947 is 3, and so on. So what is the average life expectancy for women in 1907? Right, 1907. So this is the average lifespan. They have given this average lifespan using an equation. And what is the average life expectancy in 1907? So when they say 1907, you have to plug in t equals 1 because 1907 corresponds to t equals 1 and 27 to 2027. So that you have to see what you are going to plug over here. 1907 is 1, 1927 is 2, 1947 is 3, 67 4, go on writing. And then you will see that 2027 is 7. So instead of t here we have plugged in 7. And you can simplify using the calculator. Any questions? So with this, I end today's lecture because I have something. If I am to start the next topic, it will take a lot of time, right? So I thought I will continue it in the next lecture. We won't be able to finish it within half an hour. And it's a new topic and there are a lot of questions to solve in that section. So it's a pretty heavy section. So I thought we'll do it in the next class.
Recording stopped.
So this section I went little fast. I know that you all have done most of these in school, right? So just go through whatever we did. I will upload the videos. I know last class also I couldn't upload the video yet. I will upload it. Then you can go through it and see it, right? And you can solve it on your own because all these things, I guess you have done it in school except for that LNET, right? So the next section is the most important section. I know that this week is your Urdu break, but I wanted to have the lecture because otherwise I would be able to finish. Now here, this I can finish it within one, and there are 2 more lessons to be done as well. Okay, then you all can leave. Okay, have a good break and we'll meet after Urdu.